Hey everybody, today we'll do another quick video, and today we'll do two more basic problems on hexadecimal to decimal conversion. Then we will do one example on decimal to hexadecimal conversion. I think that going from decimal to hexadecimal is easy, so I think one example will be enough. I think if you can actually do the example that I will do in the board, you will be okay with any type of problems from decimal to hexadecimal. Okay, so let's get this done, right? So let's say that we want to do this problem, right? And so let's do part A real quick, right? So we know that E is 14, right? So, but one of the things that you can actually do is just write the problem that's given to you, right? And start from the left, from the right to the left, and 0, 1, like that, right? This tells me the number of powers, right, that I have, right? In this case, I have 2 powers. So 16 to the power of 0 and 16 to the power of 1, right? So here I do what? I do 14, which is E, right, times 16 to the power of 1 plus 5 times 16 to the power of 0, right? So you take 16 to the power of 1, right? Basically 16, and then so this becomes what? Becomes 16, 14 times 16, right? Plus 5 times 1, right? Any number to the 0 power is 1, and the books, a lot of time what the books do is they just jump from this step to, and they don't bother to write, and they just, they assume that you know, but that is not my I will say my theory of teaching, of my way of teaching in this channel. It's not. I mean, that is the main reason why I actually decide to upload videos on YouTube, right? It's because I know that there are a lot of books, a lot of teachers, they just skip the steps, and they don't care if you understand or not. They just, they just skip a step, and then you try to, ask a question, and basically sometimes you don't even have a chance to ask a question. So that's why I want to do step by step, so you understand what is being done here, right? So, and then you can take this knowledge and apply it, Apply it, you're taking a class, taking digital logic class or whatever, take this knowledge and apply it. Apply it in your class, all right? Okay, so let's do this, right? So basically this is what? This is 14 times this is 224 plus 5, right? And that is equal to 229 base 10, right? So we can say that E5, right, is equivalent to is equivalent to 229 base 10. Alright, so we have that first problem. Let's do the next problem real quick. So, alright, so let's do B, right? So here I do the same thing, B2 F8. Start from right to left, writing my powers, right? So just identifying my powers, I do 0, 1, 2, and 3. Let's tell me that the highest power that I will go is 3, right? So, and then I start working on the numbers. Well, what is B? B is 11, right? B is 11. So we do 11 times 16 to the what? To the third power, right? Plus 2 times 16 to the second power plus F. What is F? F15, right? F is equal to 15, right? And 15 times what? Times 16 to the 1 power, right? Plus 8 times 16 to the 0 power, right? Okay, so let's do the math. And again, I will write everything down because I want you to understand the process, right? So 16 to the third power is equal to 4. 9 is, 4096, 11, right, times 4096 plus 256, 2 times 256 plus so this is what this I want just do a step by step again. This is 15 times 16 plus 8 times 1, right? Okay, so here because I did 16 to the 0 power is 1, right? So let's do this. Now let's do the math. So I got 11 times 4096. That is 45056 plus, right, plus 2, right? So 2 times 256, that is 512 plus 15 times 16. 15 times 16 is 240. 240 and then plus 8, right? Now just add, let's add those numbers, right? So we got a 45056 plus 512 plus 240 plus 8. And it's equal to 45,816 base 10. Alright, so we can actually say that B 2 F A 8 is equivalent to 45,816 base 10. There you have it, right? So we actually did the two last examples from going from hexadecimal to decimal, right? Conversion, right? So that's the last two examples on this type of problems. So let me do decimal to hex directly, right? So let me do decimal to hexadecimal. Right? So let's say for example that we want to go from decimal to hexadecimal, right? And we want to go directly without changing to binary, right? Or without doing any type of other conversion. So we actually can do by, technically to go from hex to decimal, you can actually do binary, right? But to go from decimal to hexadecimal, I don't know if you can actually change to binary and go back to hex. But anyway, we just go directly from decimal to hexadecimal, right? So maybe you can. I don't know if you know how to do it. Probably, just leave me a comment, right? Okay, so let's do this. So let's say that we have 650 base 10, right? And we want to go to hex, right? So we want to go to hex, right? To hexadecimal. Okay? So how we will do this? Remember when we did the binary we did decimal to binary conversion, we divided by base 2, right? Similarly here, we will divide it by base 16 because we go into hex, right? And hexadecimal is base 16, right? The only difference is that when we did the decimal to binary conversion, we use the remainder and we just wrote the zeros and ones, right? Here we had to do one more step, right? And here what we do is we divide by the base, which is 16, and then we take that number from the decimal to the right, any fraction that we get, and multiply by 16 if the number is greater than 0. But if we have an even number, for example 32 divided by 60, for example, the remainder will be 0, right? So we just write 0 for that remainder, right? Okay, so but in this case, let's see what we get, right? So we do 650, right? we take that number and base 10 and divide it by base 16, right? Okay, so we do that, right? And then, so we take that number, and so 650 divided by 16, and it's equal to, and that is 40.625, right? And but then what happened here is that I should not say equal. It just basically, this is not equal yet. It's just because I had to do a couple more steps. But let me see here, right? Just put an arrow like that, indicating that I am still doing this process, right? So 40.625, right? Now, this is when we have to this is the whole number here, right? This is the part, this is like a fraction, right? A decimal, right? I take this decimal and multiply by 16, and that is called, I would write it here, it's called hexadecimal remainder. That what it's called, right? That what it's called. When I take this number and multiply by 16, it's called a hexadecimal remainder, right? So I take that number, right? And I say 0.625, right, times 16, right? Now it's going to equal something, because that is going to equal the answer for that, not the answer, but the first remainder, right? So I said 0.625 times 16 is 10. Alright, I got my first digit. Okay, so let's do again the next one, right? So let's do, now I'm doing 40, see? Now I'm doing 40, right? Divided by 16, right? Right, and that is 40 divided by 16, right? It's going to be 2, a little more than 2, 2.5, right? So 2, so it's 2.5, right? Now you take that 0.5 and say 0.5 times 16, and it's equal to 8. Right? Now, let's do 2, right? Right, 2 divided by 16. Does 2 goes in 16? No, right? So in this case, it's kind of tricky. This is what we need to kind of pay attention here. Because if, in this case, 2 is less than 16, right? Because 2 is less than 16, I will have to kind of stop right there. I will have to stop and say that this is indeed 0, right? Because it doesn't go, right? Now, I take this number right? And make the 2 the remainder, right? Because because 16 doesn't go into 2, right? Well, 2 is less than 16, then that becomes my remainder, right? So which is 2. Now, in this case, I write I read it up like this, right? So this, the book called this LSD, right? And MSD, right? That's what they call it. Actually, no, it's the reverse. It's the reverse, I'm sorry. He call it MSD, right? And LSD, right? Most significant digit, less significant digit, right? So now we actually, how we call, how we represent these numbers, right? So what, basically this is 2, this is 8, this 10 becomes what? Becomes A. So we can say that 650 base 10 is equivalent to 8A base 16. Okay, so that is how we do decimal to hexadecimal conversion. Okay, I hope this helped, and I hope you learned something out of this video. If you like this video, don't forget to give me a thumbs up, subscribe to my channel, and share this video with your friends, or maybe with your favorite social media. Thank you for watching.